Question 1 is the first three terms of a geometric sequence R, and we're given these three terms here: x squared, 5x minus 8, and x plus 8. And we're asked to use the common ratio to show this cubic function exists. So t3 over t2 is equal to t2 over t1. That's how we find the ratio. So we get x plus 8 over 5x minus 8 is equal to 5x minus 8 over term 1, which is x squared. Cross multiplying, we get x cubed plus 8x squared equals 5x minus 8 to be squared is 25x squared minus 40x twice plus 64. Bringing everything to the left, we get x cubed minus 8x squared minus 25, that's going to be minus 17x squared. And then we're going to have plus 80x minus 64, and we've left nothing there. And then you look up and you hope and pray that these two things are the same, and you can see that they are. So we're told here, if f of x is equal to this cubic function, show f of 1 is equal to 0 and find another value of x for which f of x is equal to 0. So show that f of 1 is equal to 0. There's a couple of ways to do that. We can sub 1 in and just say 1 cubed is 1 minus 17 plus 80 minus 64 is equal to 0. 0 equals 0. Therefore, f of 1 equals 0. Or you could say, if x is equal to 1 as a root, we can divide our factor in. X minus 1 equals 0 is our factor. So let's divide that in and see what happens. You guys are experts at the box method at this point. If you are not, you should be. You need to go and practice box method long division. It's definitely the easiest way to do it. First and last terms of the cubic, x cubed and minus 64 inside, and my root on the outside, x minus 1. And if we divide this in, we're going to get x into x cubed, x squared, minus 1 by x squared is minus x squared. These two boxes give me my x squareds. I have minus 1, I need another minus 16x squared. X into minus 16x squared is minus 16x plus 16x will go down the bottom. Minus 1 by minus 16, we want 80x altogether, so I need another 64x. I have 16 in there, and x by plus 64 will be 64x, and 64 by minus 1 equals minus 64. You can always check that you're correct. So if we solve this quadratic, we'll get the other solution or solutions. This looks like a perfect square. Looks like 8 minus x minus 8 to be squared. So the other solution to this cubic, which is a double root, x is equal to 8. In part C, we're told in the case of one of the values of x, so write down your values of x, 1 and 8, the terms in part A will generate a geometric series with a finite sum to infinity. It's like the fly jumping across the table, so it's never going to get there. So this is our finite sum to infinity. So let's see which one generates this. If it's x is 1, we have 1. We have 5 minus 8, which is minus 3. We have x plus 8, which is 9. So this looks like a factor of minus 3 by 1. So our ratio is minus 3, so it's going to actually be going down and up here, so that doesn't look like it. If x is equal to 8, we get 64. 5 8s are 40, minus 8 is 32. We're dividing by 2, and 8 plus 8 is 16. So you can see here, we do have a reducing sequence. So we want sum to infinity, which is a over 1 minus r, a being the first term, r being the common ratio, which here is 0.5. We're multiplying by a half each time. So s to infinity is 64 over 1 minus a half, which is just a half, and 64 divided by a half is 128. Question 2 is a complex number question. We're given these 5 complex numbers and we're given some information about them, and we have to label them. Z2 is equal to the conjugate of Z1. Z3 is equal to I times Z1. Well, that's a rotation of 90 degrees through the origin, so it has to be this one going to the origin and then rotating 90. My eye line, it looks like that one there. That definitely looks like, if I opened it up more, will be more than 90. So that looks like Z3 and Z1 straight away. So the conjugate has to be below, so that has to be Z2 from the first one. Z2 And then we're told Z5 is equal to Z3 plus Z4. Well, if we add two complex numbers, their real numbers will increase here. So -2 and -3 go to -5. So this has to be Z5 and this has to be Z4. That's the first part. 1 plus I in polar form using radians. So if we want to just sketch the complex number, 1 plus I. So we've got a 1 and a 1, and our angle is in the positive sector. So my modulus here is √2, and my angle, the tan of A, is 1 over 1. If you can't see that, it's 45. You just get the inverse tan of 1. A will be 45, which is 180 divided by 4 in radians. So we've √2 by the cos of pi over 4 plus I sine pi over 4. Really easy maths when you know what you're doing. When you don't know what you're doing, you spend 15 minutes writing all sorts of nonsense. Then we want 1 plus I to the power of 5 in rectangular form, which is this guy to the power of 5. So applying them over it, we're going to get √2, not √5, √2 to the power of 5 times the cos of 5 times, you have to know where the power goes, pi over 4 plus I sine 5 times pi over 4. You can type this into your calculator to get it in rectangular form, but let's have some fun here. Just 2 to the power of a half to the power of 5, 2 to the power of 5 over 2. The cos of this will be 225 degrees. So a quick little jot of a unit circle to avoid using a calculator. 180 and 45 in here will be 225. CAST. So tan is the only one positive. So we've two negative sine and cos of 45s, which are both 1 over √2, or 1 over 2 to the power of a half, or 2 to the power of minus a half, if you want to write it like that. So we have 2 to the power of 5 over 2 times 2 to the power of minus a half, and we know that that's going to be a minus angle. And then we have minus, the same again, 2 to the power of 5 over 2, bringing the 2 to the power of a half up, becomes minus a half, and that will be times I. So that's 2 to the power of 4 over 2, which is just 2 to the power of 2. So we just have -4 minus 4I for part 2. First principles. Let's write the answer down. -4 minus 6x. I shouldn't really need to do this for anybody in 6th year, but if we say f of x is equal to 6 minus 4x minus 3x squared, we're going to go down f of x plus h is going to be 6 minus 4 times x plus h minus 3 times x plus h to be squared, which is x squared plus 2xh plus h squared. Simplifying this, we're going to get 6 minus 4x minus 4h minus 3x squared minus 6xh minus 3h squared. This is fx plus h. This is the reason why they've taken away rote learning off the course. So if we take away f of x, or write minus f of x underneath this, we're going to have a minus 6, a plus 4x, and a plus 3x squared. So f of x plus h minus f of x is going to be equal to minus 4h. This is the minus 4 in our answer. I'm going to write the minus 6xh next. This is the minus 6x in our answer. You can see we need to get rid of h, so the memory is divide by h, minus 3h squared. So we want this whole thing divided by h. So I'm going to just take a little shortcut and put it here. Divided by h. So f of x plus h minus f of x all over h is equal to minus 4 minus 6x minus 3h. And we say the limit of this as h tends to 0 is equal to minus 4 minus 6x. And I think that would be enough information to get full marks. Part B, we're given this function f of x is equal to 1 over x plus 2. F of x is equal to this. Show it's no turning points. So that means that f dash x or f prime x cannot be equal to 0 if it's no turning points. So let's differentiate top and bottom, we're going to get 0 on top and 1 on the bottom. The rule for quotient rule is on the bottom. We have the bottom squared. I should probably write f prime x is equal to. On the top, we have the bottom, x plus 2, by the top differentiated, which is 0, minus the top, 1, by the bottom differentiated, which is 1, which is the tongue twister. So f prime x becomes minus 1 over x plus 2 to be squared, if you want to write, which is not equal to 0, or can never be equal to 0. Therefore, no turning points. Let's see why this is. You can go on to Desmos at home, maybe. I think that's a graphing calculator. If you type it in, you'll see the shape of this graph. So the shape of this graph brings us into part 2. Is it always decreasing? The shape of this graph looks like the following. It comes like really tight to the y-axis, and it comes down here. And we just go back up to the function. I probably should have stated that x is not equal to 2. Or sorry, minus 2. X is not equal to minus 2 here. Otherwise, this function wouldn't be real. So at minus 2, we're going to have an asymptote. And all the way up to that asymptote, let's say this is minus 2, it's a bit off center. We can have no value along there. Starting after x equals to minus 2, it's going to come down, come down, come down. It's going to mirror it. It's going to come around this way. And it's going to go down like that. And I think a nice way of describing these increasing and decreasing functions, if we think about a marble, if we put a marble on the function over here, it's going to gradually, even though it's a very slight slope, go that direction and fall down. So it's going to continue to go down. We put a marble at this point, you can see it's going to fly down, like one of those old Christmas games. So if the marble keeps on moving down, we can say that yes, this function is always decreasing. Even though there's a break in the function, you could say down here minus infinity, up here plus infinity. Someone might answer, well, it goes from down here to up here. Therefore, it increases at that point, but that's not the way we read these functions. So technically, this function is always decreasing. Question 4, we're given this graph of this function, 2e to the power 0.1x, 2e to the power 0.1x. And we're asked to fill in the following table. So just set up this on your calculator and change it from, like, obviously 0 and then 0.1, 0.2, 0.3 all the way up. I'm going to round these to 2 decimals. 2.21, 2.44. You can set up the table on your calculator as well if you've been taught that way. 2.7, 2.98. Just changing it to eat the 0.1 each time. 3.3. 3.64, 4.03, and 4.45. So that's the values. Now the trapezoidal rule, the first plus the last, h over 2. So h over 2, first plus last, plus twice the rest added together. That's the way I try to remember it, so we don't have to go to the tables. So h is the gap here. They're all 1s, they'll always be the same. So we've 1 over 2. The first height is 2 from 0. The last height is 4.45. And twice the rest added together. I'm not going to write them all out here. I'm just going to type them into my calculator. Twice the rest all added together is going to give me, my rounded values, I'm getting 24.525, 24.525, and its area, so square units. And in the next part, we're asked to use integration to find the exact value. Are we asked to find the percentage error? No, just integration to find the exact value. So we're integrating y is equal to 2e to the power 0.1x. And we go to the tables. e to the power of ax. I'm writing the wrong thing. E to the power of ax goes to ae to the power of ax. So dy dx here. Sorry, we're integrating. I'm doing it the wrong way around. Getting lost in differentiation. We're integrating 2e to the power 0.1x between 8 and 0 are our bands. So this is e to the power of ax. When we integrate, we get 1 over a e to the power of ax. So this is going to become 2e to the power of 0.1x times 1 over 0.1, which is 10. So we're going to have 20e to the power of 0.1x between 8 and 0. So this is just two values. It's 20e to the power of 0.1 by 8, 0.8 for 8, and then minus 20e to the power of 0, which is 20. So I'm getting 44.51 for this one. Minus 20 is 24.51, or 24.5 square units, correct to 1 decimal place. Question 5 starts with this differentiation. So the product, we can see here x squared is one of the products and sine 3x plus 5 is the other. So differentiate both. 2x sine goes to cos, so we're going to end up with cos 3x plus 5 times the differentiate angle, which is times 3. We can put the 3 in front, 3 cos 3x plus 5. So now when we're differentiating a product rule, dy dx, the first x squared by the second differentiated, which is 3 cos 3x plus 5, plus the second, which is sine 3x plus 5 by the first differentiated, which is 2x. So just tidy this up a bit. 3x squared cos 3x plus 5 plus 2x sine 3x plus 5. And I think I'd accept full marks for that. I don't think you need to go any further. You can factor out x, but I don't think there's any point here. Although I know some of you will have, so I'll write x by 3x cos 3x plus 5 plus 2 sine 3x plus 5. Next part of this question. Sometimes they throw in these easy questions that maybe look a bit more complicated than they are. This is a cold object placed in a warm room. So it's placed when t is equal to 0. Whenever it's placed, time is 0. So here's 0 for time. So the temperature has gone from -3 up to 0 after 6 minutes. After what time interval is the temperature of the object 0? We can see here 6 minutes for our time interval. The relationship between temperature C and time is given by this formula. Temperature in centigrade is half T plus K. Find the value of K. So we have 2 points from the original graph. We have the point 0. Actually, we just go back up and look at it. We can see the slope here. We can see the slope is positive in this direction. The rise 3 over the run 6. So the slope of this line is the rise 3 over the run in the positive sense, so it's 1 over 2. And if we take the point 6 on the x-axis, 0 on the y-axis, 6 on the x-axis, 0 on the y-axis, and m being a half, y minus y1 is y minus 0 is equal to m 1 over 2 by x minus x1, which is 6. So okay, here it looks like it's equal to -6. And the last part of the short questions, if y is equal to x to the power 4 e to the power 3x, show that dy dx minus 3y is equal to 4y over x. Okay, so we have 3 different things. We want dy dx, we want 3y, and we want 4y over x. Okay, well, let's see what 4y over x is. 4y is 4 times this guy, x to the power of 4, e to the power of 3x. If we divide that by x, we're going to get 4x to the power of 3, e to the power of 3x. So we want to show that the dy dx minus 3y part is equal to that. Okay, let's look for dy dx. If it's a product, I always say write down the 2 differentiated parts. X to the power of 4 becomes 4x cubed, and e to the power of 3x is e to the power of ax becomes ae to the power of ax, so it's 3e to the power of 3x. So the first dy dx equal to the first x to the power of 4 by the second differentiated, which is 3e to the power 3x. And that's the first by the second plus the second, which is e to the power 3x by the first differentiated, which is 4x to the power 3. This is dy dx. Now I want to take away 3y, so I'm going to write it underneath. Minus 3y would be minus 3x to the power of 4 e to the power 3x minus 3x to the power 4 e to the power 3x. And we just tidy up dy dx and put the 3 in front. We can just say therefore 3x to the power 4 e to the power 3x plus 4e to the power 3x, this 4 in front, 4e to the power 3x by x cubed. And then we're going to have underneath minus 3x to the power 4 e to the power 3x. So in fact they cancel. This one and this one are the same. And that would have to be equal to 4x cubed e to the power 3x. So we can see here it is. We just have them in a slightly different order. So 4x cubed e to the power 3x is equal to 4x cubed e to the power 3x quad erat. Demonstrandum. You have finished the short questions.